Hi, thank you for tuning in to my channel. My name is Mihai and in this video I'm going to introduce you to some of the features and technical details of my final year project. My proposal is to build a hardware and software infrastructure for a network of drones connected to the internet through the LTE mobile broadband. This would allow users to operate a drone and stream live video from a long distance in relation to where the drone is located. Another example would be medicine delivery in an emergency context. The drone could carry up to 450 grams of payload. Assuming 10 grams per dose, this would equate to 45 vaccines being delivered by a single drone from air. The delivery of this project is simple. I intend to use cheap and readily available parts and design custom hardware to cut weight. In the background you could see the custom PCB that is going to elegantly package all the necessary hardware, including a Raspberry Pi Zero, an 8-bit microprocessor and 5 sensors. The sensors are an inertial measurement unit composed of an accelerometer, gyroscope and magnetometer, then a barometer and a power meter. Combined, all these sensors would allow the drone to be stable in air, hold altitude and report the remaining battery to the user. Last but not least, it also packages the power delivery system for all the components, including the 12-volt lines for the motors. The motors are high-torque 920 kV brushless using 3-phase direct current. The battery of the drone has a capacity of 6000 mAh and can sustain a flight of 38 minutes with a payload of 280 grams. The arms of the drone are from the DJI F450 frame and are made from plastic. One of the drawbacks of these is the weight-to-span ratio, and I'm thinking about upgrading to carbon fiber tubes instead. As I said earlier, the server is hosted on the drone and clients have to connect to the drone from a phone application. Currently, the project is only supported on Android devices. The drone is controlled using an Xbox One controller connected to the Android phone. One of the challenges of this project was to create a good user experience by generating a set of controls for the Xbox gamepad, which is designed for gaming. I had to build several prototypes in order to get it right, and it made the difference between a stable flying drone and a drone that would crash 5 seconds after takeoff. One of the drawbacks of connecting the phone to the Bluetooth controller is the latency introduced by the Bluetooth technology, which averages at 155 milliseconds. This problem can be solved by simply using a cable to connect the two devices. I personally find it hilarious that two devices that are less than 5 centimeters apart take 150 milliseconds to communicate, in contrast with the latency between the server and the client, potentially situated 250 miles away, which is only 80 milliseconds. But back to the drone. Once powered on, the drone automatically connects to the 4G network, and the Raspberry Pi launches a server application which has multiple roles as follows. It communicates to the I2C power meter on the board to read battery voltage. It sends data to the Pi located in the 8-bit microcontroller via an analog protocol, and it handles the client messages using a custom protocol called Hawk1. Hawk1 is a protocol designed with simplicity in mind. It is implemented using both TCP and UDP, and it features a low number of headers in order to minimize the packet size. Because of this, the frequency of the packets can be high without affecting the cost of operation, having a maximum bitrate of 18 kilobytes per second when sending 300 packets per second. This means that the latency can be kept very low without increasing the cost of the data plan. What you are going to see next is a demonstration of the drone flying. Next, I'm going to use the drone to shoot some aerial footage. Unfortunately, the video stabilization could not cope with the jerk of the commands that I was sending from the remote. In the future, I intend to install a gimbal to the camera to fix this problem. I hope you enjoyed the project. Thank you for watching and I'll see you next time.